So we can show these inequalities on the graphing tool on Desmos. And so when I graph 2x minus 5y plus 1 is less than 0 on the graphing tool, okay, I get a graph that looks like this. So there's my x and y axis. Okay, I get a graph here, and the slope of this is about 2/5. Okay, oops, it's not equal to, so I need to show it as a dotted line. Okay, and then I'm shading in this portion of the graph. Okay, so that means that all these points in that red region must satisfy the inequality. So this point 0, 0, that's our test point, because 0, 0 is a really easy coordinate to test. So when I do my test point here, okay, so I get 0 minus 0 plus 1 is less than 0. That's not true. Okay, so that shows me that that coordinate is not part of the solution region, so this portion above must be. Okay. Now we could also graph this on a graphing calculator. Okay, we can solve for y. So when I solve for y, I get 2x plus 1 is less than 5y. Then I get y is greater than, I'm going to divide by 5, 2 over 5x plus 1 over 5. So you can see that the y greater than indicates above the line. Okay, so this represents my function, 2x over 5 plus 1 over 5. That's my function. My y coordinate should always be above the function, which is that line. So it says here, is 0, 8 a solution? Again, I tested 0, 0, but we can also test 8, 0. Okay, so when I test 8 over 0 up, that's a coordinate right about here. Okay, so there's 8, 0, and we should expect this not to work. Okay, so when I test 8, 0, I get 2 times 8 minus 5 times 0 plus 1 less than 0. Well, 17 is not less than 0. That is not a solution. Okay, so it is not part of the solution region, and the solution, again, remember, for a two variable inequality is an area or a whole bunch of x, y coordinates. So moving on to this one here, this is, again, we can just plug this into our Desmos, into our graphing tool. Our graphing tool can accommodate this type of equation quite easily. So when I graph this on my graphing tool, I'm going to get an equation that looks like this, and since it's equal, okay, I'm going to have a line that looks like that. Okay, and the shading is going to be on this side of the line. Okay, so again, I should test this. I'm going to test a point, and again, my test point should be 0, 0. So I'm going to test 0, 0. So when I plug that in, I get 0 plus 0 is greater than or equal to 3. That's not true. Okay, and we can see that that does not satisfy the inequality on our picture either. Okay, those points there are our solutions. If I test 6 and 4, okay, 6 over 4 up, okay, looks like it's about there. It's hard to tell, but it looks like it's kind of on the line. So I'm just going to test it. 6 over 3 plus 4 over 4 is greater than or equal to 3. We get 2 plus 1 is greater than or equal to 3. It's equal to 3, so that's part of our solution. In fact, it's on the boundary line. Okay, so it does fit the inequality because we include the boundary line because of that equals. So we can always graph this in our y equals as well, and we should make sure that we're able to convert this into a y equals form. So I'm going to multiply everything by 4. So I get 4 over 3x plus y is greater than or equal to 3. Solving for y, I get negative 4 over 3x plus 3. Oh, sorry, that's not going to be plus 3, it's plus 12. Okay, so it's going to be plus 12 here. And so we end up with that linear equation, negative, it's got a slope of negative 4 over 3x. Yeah, that's true. And we know that the y is bigger than the boundary line, so it should be above, and we can see that indeed we did shade above the graph. So the solution to inequality is the area. So we can describe the area relative to the boundary line, and it is the area either above or below the boundary line. Okay, so it's either, I'm going to write it this way, it's either above the boundary line, okay, and that's when the y is greater than or equal to, or y is greater than, okay, our function, and or below the boundary line, when y is less than or equal to, or y is less than the boundary line. Okay, so we can determine which region of our graph by testing. We could also do this by using that, looking at the inequality for the y value. So if we make it into y equals mx plus b, the y is our function, or the y is a y coordinate. The expression on this side represents our function. So this is our function. The y values that are above that function are ones that we can include in our solution set.